So now I'm going to move to random forest, which according to the paper is the best one. So in their paper, they also got it to just make three mistakes as well. So that's sort of the benchmark we're doing. But they use binary accuracy and they use F1 and other things that can be biased because of this sort of imbalance. I think they try to use weighted averages to make it a little bit better, but again, here we are, using, now I'm doing random forest. And with random forest in this situation, I will do this later, but for now, I'm just doing n estimators and max depth. So I'm not doing minimum samples per leaf or max features. Sometimes having too many, if like I said before, it'll mess things up. So, because you'll have something that is suboptimal and then it'll just mess up everything else. So just be careful. So when you start out, start simple and then try to go more complicated. And if it doesn't work out, you want to go back to simple at that point. You always want to have in mind how it would do on a baseline level, like without any optimization, so that you never sort of lose sight of that as your benchmark. So I want to use SKF again. So I want to use the same cross-validation scheme. And here I'm using a random forest classifier with the number of estimators and the depth as really the only hyperparameters. Again, we are cross-validating this particular regressor over the entire data set. We're using Matthews to score. We're using the same RSKF, so this should be RSKF here, repeated stratified k-fold. And the p-bounds for the parameter bounds for the estimators, in this case, again, sort of the typical thing I've been doing for all the tree ones, 40 to 500. The depth will be 2 to 12. I guess it could probably up that to like 15 or something. But anyway, so we're calling this whole thing RF opt, and then we're basically creating this optimizer object, and it's optimizing the RF opt using those parameters and those bounds. And here again, I'm going to go with 2 initial points to be fair, and again, 20 iterations. So let's run this and see how it goes. And random forest is not quite as fast as LGBM. I'm going to skip over XGBoost. I may do it later myself and then add it, but right now let's just deal with this. So right now we're off to a pretty good start. We have a 94.34 using a max depth of 9 and looks like about 169 in terms of the estimators. And now we have a new champ, 94.74. Max depth is 12 with 405 estimators. And so you can see that there's a wide range here. So it hits 77 here, which is not surprising because it has a really low depth here, so it doesn't have the expressiveness. You definitely, in order to sort of reach peak random forest value or performance, you sort of need to have the estimate, the depth, I guess, be at least 9. And the estimators, I guess, it doesn't really matter a lot, I don't think, because here you have 170 and here you have 400, and really here you have 280, and they give you about the same value, supposedly. So, it's because, of course, like you can say, you can't assume that the optimal values for any of these things follow some kind of Gaussian distribution where there's one sort of mean, which is the best. It's always, it often depends on the data set, right? So if you're cross-validating and you're sort of randomizing, then it'll always be a little bit different. And, it could be bimodal, like there could be sort of two sort of ranges that are good. So 94.75 is sort of our peak here, and it involves us with max depth of this and estimators. Again, we'll round these, right? So that our max depth is 11 and our estimators is 280. Then, of course, I take these parameters, the 11 and the 280, and I put them into the classifier. I don't think warm start is that important, but anyway, it's there. And again, a cross-val score of this thing over x1 and y1 with the repeated stratified k-fold and MCC as my scoring. So I'll run this, and the results should be pretty interesting. So here you can see that the average cross-val score is 94.7. And when it comes to the overall data set, it's the same. It makes three. I mean, who knows if it's the same three, but it makes a mistake on three of them. But again, how does this compare? 94.7. So let's go to the other ones and sort of remind ourselves. So if I go back to Cat Boost, I can see that my overall was 93.7. So that basically means that random, although they only made 3 errors as well, but I mean, I guess you would say that random is better than Cat Boost. If you look at LGBM, the light GBM, and you go down, you'll see the score was 93.7 as well. So that's also in the ballpark, but it's not quite as good as Random Forest, which we now see has the average score of 94.7. Okay. So let's take a look at the SHAP values here. So we're basically looking at the SHAP values here. And again, you see polyuria, polydipsia, gender. This time, I don't think sudden weight loss was an important one before, but now it's sort of become pretty high up there. Paresis was one of the unimportant ones in some of the earlier algorithms, and now it's something kind of important. Alopecia always seems to be somewhere in the middle. Age has gone down a bit. So age was usually kind of higher up a little bit or in the middle. Now it's sort of in the bottom. It's one of the bottom ones, and I think weakness is still pretty low, I think, and obesity sort of seems to be generally not one of the important ones. So again, it's these few. It's the only thing that seems really clear is that polyuria and polydipsia are the top two.